Okay, today we're going to look at the gradient of a curve. Now, in the space here, I'm going to draw a general curve. Okay, something like that. I'm going to put 4 points on the curve in different positions. Now, as you move along a curve, the gradient at each point on the curve changes because a curve is always changing direction, so therefore its gradient is going to change. Now, we could calculate the actual gradient at each point on the curve by drawing a tangent to the curve at that point. So let's say, for example, we wanted to get the actual gradient at this point here on the curve. So what we could do is we could draw a tangent to the curve. So remember, a tangent is just a straight line that touches the curve at one point. So we could draw a tangent to the curve at that point, and we could calculate the actual gradient of the tangent. So the actual gradient of this red line would give you the actual gradient at this point on the curve. And you could do exactly the same for the other points. Now, the good news is, however, you don't actually need to draw a tangent in order to calculate the actual gradient at any point on a curve. Instead, what we're going to do is we're going to differentiate the curve. In other words, we're going to get dy by dx. Now, dy by dx has a meaning. Dy by dx represents the general gradient of a tangent at any point on the curve. So to get the gradient, the actual gradient at a point on a curve, the first thing you'll do is differentiate the curve to get the general gradient, dy by dx. Then what you'll do is you'll sub the x coordinate of that point into the general gradient, and that will give you the actual gradient at that point on the curve. So we're going to look at that now with our first example. So if we take a look at example 1. So there is our curve, and it asks us to find the gradient at the point in this curve where x is equal to 2. So we want to get the actual gradient at the point in this curve where x is equal to 2. Now, we start off with our curve. When you hear the phrase gradient, you should think dy by dx. So what we're going to do now is we're going to get the general gradient dy by dx. So we're going to differentiate the curve to get dy by dx. And we've got the green light to differentiate because remember, there's no roots, there's no brackets, there's no x's on the denominator. So let's differentiate. So we're going to get dy by dx. And that's equal to. So differentiate the first term, we're going to get 6x. Differentiate the second term, we're just going to get minus 2. And then remember, when you differentiate a number term with respect to x, it just disappears. When you differentiate an x term where the power of x is 1, you just are left with a coefficient of x, which is just minus 2. So what we have here is the general gradient at any point on the curve. What we want to do now is get the actual gradient where x is 2. So we're going to get actual gradient at x equals 2. So what we do now is we sub the x coordinate of the point, which is 2, into the general gradient to get the actual gradient. So we're going to get 6 and then replace x with 2 and then subtract 2. So we're going to get 12 minus 2 is just going to give us 10. So what we've done is we've worked out the actual gradient at the point on the curve where x is equal to 2. So that is our answer for part A. Now, part B then says, what are the coordinates of this point? Now, we already know the x coordinate of this point. We now want the y coordinate of the point. Well, if you know the x coordinate or the y coordinate and you want the other one, you just sub it into the curve because the point lies in the curve. So we're going to get the y coordinate of the point. So we're going to sub the x coordinate into the curve. So we've got y equals 3 and then replace x with 2. So that's going to be 2 all squared. And then minus 2. And then replace x with 2. And then we're adding on 1. So tidy it up, we've got 2 squared is 4, 4 threes are 12, and then 12 minus 4 is going to give us 8, and then 8 plus 1 is going to give us 9. So the coordinates of the point is 2, 9. And that's our answer for part B. Now, just to go a wee bit further, I'm going to draw a sketch here to illustrate what has just happened in this question. You don't need to draw a sketch, but I think it's useful to help you understand what's happened. So what we have here is a quadratic curve. Highest power is 2. A coefficient of x squared is positive, so it's a happy shape. So we have something like this. Happy shaped quadratic. Now, what we've just discovered is that at the point 2, 9, the gradient is 10. So 2, 9 must be somewhere over here. Your point 2, 9 must be there because the gradient at that point is positive. So if I were to draw a tangent to the curve at that point, the tangent would be sloping upwards. In other words, it would have a positive gradient. Hopefully you can appreciate that. So this is our point 2, 9. And we've worked out the actual gradient at that point is 10. And what that means is the actual gradient of the tangent at that point is 10. So, quick summary of the question. When you're asked any question to do with the gradient, you should be thinking dy by dx. So, you start with your curve, you differentiate the curve to get dy by dx. dy by dx is the general gradient at any point on your curve. Once you've worked out your general gradient, you then sub in the x coordinate of the point to get the actual gradient. And then if you want to get the y coordinate of the point, well, it's very simple. You just sub the x coordinate into the curve. And that will get you your y coordinate.